Hello, this is your host, Austin Browder, and welcome to another episode of Real Sci-Fi, where we explore the thin line between science fiction and reality. Today, we will be discussing the sci-fi trope of cloning and cloning technology in the real world. Then we will be diving into frequently asked questions about real-life cloning. So let's dive into it. Many of you listeners have surely seen clones in popular sci-fi media, whether that be the clones in the Star Wars prequels or the clone of Wolverine in Logan. In all of these examples, however, animals or humans are the subjects being cloned, but in reality, cloning technology is not there yet. Real-life cloning technology is being used to clone plants. Now, I want to point you listeners' attention to something very important. All of the appearances of cloning in media that I talked about have something in common. The clones are being made to be superior versions of the base animal being cloned. This is very similar to what's happening in reality with micropropagation, a method of tissue culture used to create clones of plants, specifically plant seeds. According to Rashid, a local expert on the subject of micropropagation, it is used to enhance the yield and quality of crops massively by specifically cloning elite versions of a seed. Now, for the first question of the evening. Question number 1. What else can micropropagation and other seed cloning technology be used for? According to Gossel, one of the local scientists for micropropagation, one promising thing this technology will be used for is the rejuvenation of old varieties and clones of vegetatively propagated crops for improving their yield and quality. This entails that varieties that weren't viable for farmers to produce in the past will be able to be produced viably with micropropagation technology. Gossel also points out that novel variants that either do not exist or are rare in the natural gene pool can be produced using micropropagation. With current seed cloning technology, individual genes can be isolated and cloned. Gossel also said that unlike conventional breeding, only the cloned genes of agronomic importance are introduced without co-transfer of other undesirable genes from the donor. Useful genes, like ones that improve disease resistance, pest resistance, nutritional quality, and yield, are cloned for use in plants. This really shows that micropropagation has a big future in improving seed quality. And now for question 2. A popular one in society today, are organic foods less risky and or healthier to consume than genetically modified foods like the ones produced through micropropagation? According to one of our experts on the subject, Rimbichkafi and his partner Kalas, foods that are considered more natural, such as organic foods and GMO-free, are normally perceived as less risky / more healthy than genetically modified. Even though this perception is held by so many, it is wrong. When crops are modified, they remain substantially equivalent to the unmodified parent, with the exception of one or a limited number of identifiable characteristics, according to our other local expert, Perret. The only characteristics that are changed are ones that improve the plant, such as, again according to Perret, resistance to diseases, pests, and good nutritional quality, along with enhanced productivity. When traits like diseases and pest resistance are improved for a plant, harmful chemicals and pesticides don't have to be used on that plant. Therefore, it is indeed safer. On the other hand, organic plants that already aren't protected often have to have pesticides used on them. In conclusion, genetically modified foods are often less risky and healthier than their organic counterparts. On to question 3. Why can't small-scale farmers take advantage of tissue culture technology? The major reason small-scale farmers can't take advantage of tissue culture technology is because of patents. If a unique DNA sequence is invented for a plant, the inventor can patent the sequence. Private corporations that have the funds to research DNA sequences can patent their own to create elite seeds or buy the already existing patents. According to our local expert Konstantinov, most public research is being directed to a greater extent towards satisfying the desires of the firms that purchase the right to the patents, and to a lesser extent towards the desire of farmers, ranchers, and consumers. Small-scale farmers simply can't afford to purchase the patents for elite seeds or fund the research to invent their own. Because of this, small-scale farmers are forced to rely on conventional breeding methods that are vastly inferior to genetically modified elite seeds. In conclusion, the ability to patent plant DNA sequences and the cost to independently research them are the reasons why small-scale farmers can't take advantage of this incredible cloning technology. So, in conclusion, cloning technology is very real and currently being used, just not in the way people might first think after watching sci-fi media. However, the real cloning technology of micropropagation has potential to improve farming and society as a whole. The only downside to this technology is that small-scale farmers are being put at an even greater disadvantage to big corporations because they can't afford the micropropagated seeds. That is all for this episode of Real Sci-Fi. This has been your host, Austin Browder. Peace.